We present CHSEL, a pose estimation method that uses volumetric information to estimate a diverse set of plausible poses. This is particularly useful when occlusions prevent reliable visual sensing in contact-rich tasks where only sparse surface information may be retrieved from each contact. In these cases, a single estimate is less useful than a set of plausible estimates for downstream tasks. To that end, our method Constrained Pose Hypothesis Set Elimination, or CHSEL, comprises two main components. We formulate a differentiable cost function using the object's sign distance field, SDF, and volumetric information, such as whether a point is known to be in free space, occupied, or has a certain SDF value. The most common SDF value to be known is 0, which is the object surface. We optimize this using quality diversity techniques to produce diverse plausible pose estimates. See the paper for more details, please. Now, we show our real robot probing experiment, where we estimate the pose of a partially occupied object in a cabinet through probing it. Note that this view is not available to the robot. Free points come from both the camera and the swept volume of the robot, while known SDF value points are collected from contact. Note that the camera is unreliable near occluding edges, and so we only use it to provide free space. In other situations, when combined with segmentation, it can also be used to provide known surface points. The optimal object pose, computed in hindsight, is shown in purple, while the plausible set of poses given the current data is shown in blue. Note that even probes that do not make contact provide free space information that can be used to constrain the plausible set. This process continues for the duration of the fixed probing policy. Future work could use the estimated plausible set to reason about where to probe next to most efficiently gather information. Our goal is to estimate the plausible set, and following, we will show our method against baselines and ablations after each of the probes when given the same data. See the paper for more details. Next, we show some simulation results. Similar probing experiments are performed across the YCB objects and configurations over 10 trials. We focus on a single experiment in this video. Unlike the soft bubble sensor, the simulated gripper is rigid and makes single point contacts, making the surface point data even more sparse.